So let us start our discussion today. So we are going to discuss a new topic today under our unsupervised machine learning concepts. So what are we going to discuss today? Association rules. So just 1 second. So association rules is another unsupervised machine learning concept. So what is the concept of association rules is? We have to identify what are the items which can be purchased together, or we have to identify what are the items which are associated with each other. That is the objective of this algorithm first. What item can be purchased with what item, or what item is related to what item first. For example, simple way to understand this concept is suppose if a person is going to the supermarket and if he is buying fruits, then he can also purchase vegetables first. So fruits and vegetables are associated with each other. If a person is buying bread, then he can also purchase butter. He can also purchase jam, cheese. All these are associated products for us. They are related products for us. So our objective is to find out these kind of products which are associated with each other. Suppose if I buy cricket bat, then I can buy cricket ball, I can buy pads, I can buy gloves, wickets. All these are associated products. If I buy shoes, I can buy socks, I can buy belt, I can buy tie. All these are again associated products for us. Shoes, socks, belt, and tie. So our job is to find out these kind of related products for us. This is the concept of association rules. So association rules is also called as a priori algorithm, or you can call it as affinity analysis for us, or you can call it as market basket analysis. All these are different terms that you can have for our association rules concept. So with this background now, we are in a position to understand the remaining concepts in association rules. What are they? Let us try to understand one by one. So association rules is nothing but it is study of what item goes with what item first? Study of what item goes with what item? It is also called as market basket analysis or affinity analysis. If I buy a mobile phone, then I can also buy a cover for my mobile phone. These are associated products. That is the idea. Our job is to identify these kind of associated products first. If I buy geography books, then I can also purchase drawing books. I can also purchase self-help books. I can also purchase do-it-yourself books. So I want to find out what are these associated products. So what is the first thing we are supposed to do? We have to study the customer transaction database. That is the starting point for our analysis. We have to carefully study customer transaction database and then find out what are the different items which can be purchased together. What are the different items that can go hand in hand? We have to understand. That is the purpose. What item goes with what item is we have to discover by understanding the customer transaction databases first. So what you can do to understand the customer transaction database, you can simply take the help of the items what the customer has purchased. You can study the basket of items what the customer has purchased, and then based on this basket you can find out what are the products which he has purchased together. So this is one thing that you can do to understand the customer transaction. What is the second thing that you can do? You can also study the customer transaction history from his membership card or loyalty card. So if you study the loyalty card, then it is going to give us information about what are the possible products that can be purchased together by our customers. So you can get an understanding that what are the possible products which can be purchased together by a single customer. You can understand that by taking a look at your customer transaction history. So any method you can use to understand what is the buying behavior of the customer. This is the idea. Now, let us take a look at one simple example first. What is that example is? Walmart has discovered a mysterious association between beer and diapers. So what did Walmart discover? There is an association between my beer and diapers. That is what it has discovered. So if customers purchase diapers, then they would also purchase beer. This is the association what Walmart has discovered in their stores. So they found this pattern in 50 of their stores across 90 days. They have studied this behavior and they have discovered that there is a mysterious association between beer and diapers. What is the background story for this? The background story is probably mom was calling dad at work to buy diapers on the way back home. And then dad also decided to purchase 6 pack of beer when he purchased diapers. So when he was buying diapers, he also decided to purchase beer. So this is the background story. Now the question is how Walmart can utilize this association. How Walmart can apply this association rule for improving its business. How Walmart can develop a business strategy using this association rule. That is the idea, what we want to understand. Now, what Walmart can do, for instance, it can move diapers and beers to separate places. It can move diapers and beers to separate places. And Walmart can position all the high profit items of interest. It can position all high profit items of interest to young fathers along the path. So when the father is walking along the path to buy diapers and beer, he is going to come across all these high profit items. And he may also think of purchasing those products. So what is the shopkeeper trying to do? What is the retailer trying to do here? It is trying to cross-sell its products. That is what is happening. It is trying to cross-sell its products. So this is one of the strategies whatever businesses can use. How to position your associated products in the store. And you can take the advantage of this association for cross-selling other products in your store. If you go to a travel store, if you think of purchasing suitcase, you think of buying a suitcase, then the shopkeeper is also going to try and sell you a laptop bag. He will always do this. He will try to cross-sell one of his products. And what is he going to say? He may say that you can purchase both these products together and I'm going to give you some price discount. So what is the shopkeeper trying to do? He's trying to bundle these two products together, which have association, your suitcase and laptop bag. And then he's going to offer you some bundle price discount. So this can be another strategy, whatever businesses can use. Suppose if you go to Burger King or McDonald's, what is happening? They are going to sell their burger. Along with burger, they are going to sell French fries. Along with French fries, they are going to sell you Coke. Along with Coke, they may sell you ice cream. So all these are associated products. They're selling these products together and they're going to call it as a meal. And they are going to offer you some discount on the meal. So all these are strategies what businesses can apply and improve their revenue and profits. That is the idea. So businesses can cross-sell the products. They can promote items together. And in doing so, they can also increase the price of other related items. So they can always do this. That is the idea. So we have to keep in mind how association rules can help us in deciding how to position our items in our store, how to use our association rules in developing strategies like offering price discounts, and how it can also help us in managing the inventory of associated products in our store. So many applications are there where you can use the concept of association rules and you can help the business. That is the idea. Now, what do we mean by association rules? Association rules means they are if-then statements. What are they? They are if-then statements. So if I'm buying bread, then I can also buy butter. So if A, then B. So association rules are nothing but they are if-then statements for us. So we basically have to write down these kind of if-then statements. So A means antecedent. These are technical terms. We are going to use them. So we have to remember. A means antecedent item. B means consequent item. So A means antecedent item for us. B means consequent item. So what can be some examples for us? If a person is buying computer, then he will also purchase financial management software. So what is your antecedent item? Antecedent is computer for us. What is your consequent item? Financial management software. If a person is having the age of 30 to 39 and income $42,000 to $48,000, then he is going to purchase a car. So what is your antecedent item? Age 30 to 39 and income $42,000 to $48,000. This is my antecedent item. What is my consequent item? Car. So like this, our job is to write down if-then statements. And then we should be in a position to find out what are our important if-then statements that we can use in our business. We have to find out what are those important association rules which can help us in our business. That is the idea. So the first step is writing down our if-then statements or association rules. That is the first step, what we have to do. Now, what kind of association rules you can come across when you are trying to create from your data sets? What kind of association rules you are going to observe when you generate using your customer transaction databases? So there are three types of association rules what you are normally going to observe. What are they? The first type of association rule is called as actionable rules. What is the meaning of this? Our association rules are going to contain high quality information and actionable information. So these association rules are going to contain high quality information first. So I can use this high quality information in my business. I can take some decisions on the basis of this high quality information, and I can see how is it going to affect my business. That is the meaning of actionable association rules. You can also observe that your association rules can be trivial association rules. What is the meaning of trivial? Information which is already well known by those who are familiar with the business. These are unimportant association rules because the information is already available in the public domain, and we are no longer in a position to use this piece of information and develop our business. So these kind of rules are called as association rules for us. Trivial association rules. Now, there can be another category of association rules which are called as inexplicable rules for us. What do you mean by inexplicable rules? There is no logical explanation that can be provided to these kind of association rules. Therefore, we do not recommend any action on the basis of inexplicable rules. So it is not recommended to take any action using our inexplicable rules. If you are working on some random data, so there is a possibility that you may discover mysterious association rules from your random data. So these mysterious association rules can be categorized as inexplicable rules, which are not having any logical explanation, and therefore it is not recommended to apply them in our business. That is the meaning what we have to understand. So most of the time when you are working with the concept of association rules on our data sets, there is very high chance that all the rules what we are going to create can actually be categorized as trivial or inexplicable rules. There will only be very few association rules using which we can take decisive action and apply them in our business. So that is the idea what you are supposed to understand. That is the overview or information which is required for you to focus on only those association rules which are actually going to have high quality information for us. So what are the examples of our actionable association rules? What are the examples of our actionable association rules? Let us see. Let us discuss some experiences of different companies. Walmart, for instance, has discovered that customers who purchase Barbie dolls have 60% likelihood that they also purchase one of the three types of candy bars. So customers who are going to purchase Barbie dolls have 60% likelihood that they are also going to purchase one of the three types of candy bars first. So this is an actionable association rule, what Walmart has discovered. Then customers who purchase maintenance agreements are also very likely to purchase large appliances first. So customers who are purchasing maintenance agreements are also most likely to purchase large appliances first. This is the experience of Linoff and Berry. It's another company. So this is another actionable rule, what this company has discovered in the past. We have another example. When a new hardware store opens, one of the most commonly sold items is toilet bowl cleaner. This is the experience of again Linoff and Berry. Whenever a new hardware store opens, the most commonly sold items is toilet bowl cleaner first. So there is a association between your hardware store opening and our toilet bowl cleaner being sold. So like this, we should also develop our actionable association rules, which are going to contain high quality information. That is important for us. Which are going to contain high quality information for us. So for applying the concept of association rule, let us first discuss what is the problem statement. What is the problem statement that we are going to solve? And understand the concept of association rules we are going to discuss. So the problem statement is, there is a store that is selling accessories for cellular phones. And it is running a promotion on faceplates for us. What is faceplate? It is nothing but cover for your mobile phone. Cover for our mobile phone. So what is this offer? If you buy multiple faceplates from a choice of 6 different colors, you are eligible for getting a discount. So if a customer is going to buy multiple faceplates from a choice of 6 different colors, he is going to get a discount. So we have 6 different color of faceplates. 6 different covers we have. Now, the store manager wants to understand what color of faceplates customers are likely to purchase together. So he wants to study what color of faceplates my customers are going to most likely purchase using this offer. So this is the problem statement that we have. So what is the first step? The first step is we have to understand what is the customer transaction database. So after running this offer, what kind of transactions my customers have made, I have to study them. Only then I can find out the association between my different color faceplates. So that is the first step, what I have to do. Now, this is the data what we are getting from first week of promotion. So we are taking a snapshot of transactions. A sample of transactions we are trying to understand. So how many transactions we have? We have 10 transactions. So in the first transaction, my customer has purchased red color faceplate, white color faceplate, green color faceplate. In the second transaction, my customer has purchased white color faceplate, orange color faceplate. In the third transaction, my customer has purchased white color faceplate, blue color faceplate. In the fourth transaction, my customer has purchased red color, white color, orange. In the fifth transaction, my customer has purchased red color faceplate, blue color faceplate. So like this, 10 transactions are there. So this is our transaction database. Now, we have to first write down our association rules on this data set. So association rules are nothing but if-then statements for us. Association rules are nothing but they are if-then statements. Now, what is the basic idea? What we are supposed to have? We have to examine all possible association rules using the if-then format. And then we have to select only those association rules which are going to indicate the true dependence between our products. So we're going to only focus on what are those items or products which are having true dependence, which are truly associated with each other, and we are going to decide whether to apply them in our business or not apply them in our business. That is what we are going to decide. So let us see what is that we can do. So if you start from your first transaction, if we start from transaction 1, we can understand that many association rules we can write. We can understand that many association rules are possible for us. So if red, then white. This is one association rule what I can write. So if a person is buying a red color faceplate, then he is also going to purchase a white color faceplate. This is the first association rule that I am writing. What can be my second association rule? If white, then red. If a person is buying white color faceplate, then I can, or he can also purchase a red color faceplate. This can be another association rule for us. What can be the third association rule? If a person is buying red and white color faceplate, then he can also purchase green. So like this, several possible association rules can be generated for us, can be written down for us. What is the problem that we are going to face when we have so many association rules? The computational time is going to increase exponentially as you start writing more and more association rules. Why are you writing more and more association rules? Because the number of items are increasing. What the customers are purchasing. So as the number of items are going to increase, more and more association rules you have to write. And if you start writing more and more association rules, the computational time required to process these association rules is also going to exponentially increase for us. That is a challenge what we are going to face. That is the difficulty what we are going to have. So how can you overcome this problem of computational time? That is the next question. So what is that we have to focus on to overcome this computational time difficulty what we are going to face? So the solution for that is we are going to use a measure called as support. We are going to use a metric which is called as support for us. So what is support going to do? Support is only going to focus on frequent item sets first. It is only going to focus on frequent item sets. What is the meaning? It is only going to consider those combination of antecedent and consequent item sets which are occurring with higher frequency in our database. So if we focus only on frequent item sets which are being purchased together, then you can reduce or you can overcome the computational time required. That is what we are going to do. So we are only going to focus on what are those frequent item sets which are present in our database. So take the help of our metric support. So support, what is the definition? The definition of support is percentage of transactions in which antecedent and consequent item are appearing in your data. What is the definition of support? It is nothing but percentage of transactions in which your antecedent and consequent item are appearing together. So how you can write down the formula for support? In the denominator, you are going to have total number of transactions. In the numerator, you are going to have number of transactions with your antecedent and consequent item. This is the formula for support. So write down the formula. What is the formula for support? Denominator, you are going to have total number of transactions, and in the numerator, out of these total transactions, how many transactions are having our antecedent and consequent item sets. This is the formula for support. Now, if I give you one question, to find out the support, can we solve those kind of questions? Let us try to understand. If I give you one association rule as an example, is it possible for us to find out what is the support for that association rule? So let us try to calculate our support and then find out. So we have an example here. What is the support for association rule if white then blue? This is the question. So it is a multiple choice question. You have 4 options and you have to select from one of the 4 options. Which option is correct? So this is our data set that we have. So what is the question? What is the support for if white then blue? What is the answer? Let us try to find out. Support formula is denominator is total number of transactions. How many transactions we have? 10 transactions we have. So out of these 10 transactions, how many transactions are having white and blue? 1, 2, 3, and 4. So 4 upon 10, 40% is the support for our association. That is the answer. 40% is the support for our association rule if white, then blue false. So that is how we are supposed to answer these questions first. Now, suppose if I give you another problem. What is that problem is? What is the association rule that we have if blue, then white? So the question is, find out what is the support for our association rule if blue, then white. Again, it is a multiple choice question. Let us try to answer. What is the formula for support? Denominator, you have total number of transactions. Total number of transactions. And numerator, you have number of transactions with antecedent and consequent item set. So what is your antecedent here? Our antecedent is blue. What is your consequent item here? It is white. So now, out of 10 transactions, how many transactions are having blue and white? 1, 2, 3, and 4. So 4 upon 10. Again, it is 40% false. So support for this association rule is 40%. Now, what is the important point that we have to understand here is, when we are trying to find out the support, the order in which the items are purchased is not important for us. The order in which my items are purchased is not important for us. This is the understanding what we are supposed to have. The order in which items are purchased is not going to play an important role when you are trying to calculate our support. That is the idea. That is what we are supposed to understand. Now, what is the second measure that you can also use to shortlist? What are those important association rules that can help us in our business? What is the second performance measure you can use? It is called as confidence. This is the second metric that you can use. It is called as confidence. What is the definition of confidence? Confidence is nothing but percentage of antecedent transactions that are also going to have your consequent item set. So what is the definition? Percentage of antecedent transactions which are also going to have your consequent item set. So how you can write it mathematically? P of C given A. Given that you have your antecedent items, how many of these transactions with your antecedent item we are also going to have our consequent item? That is the meaning of confidence for us. So how can you find out now your confidence? So same problem, let us try to consider. So what is the confidence now? For our association rule, if white, then blue. What is your antecedent item? It is white. What is your consequent item? It is blue. So confidence formula is total number of transactions with my antecedent item. So how many transactions I am having white in my data set? 1, 2, 3, 4, 5, 6, 7, 8. So 8 transactions I'm having my antecedent item. Out of these 8 transactions, how many transactions are also having blue, my consequent item? 1, 2, 3, and 4. So 4 transactions are also having my consequent item. So what is the value for confidence? So confidence for our association rule is 50%. That is the answer. 4 by 8 or 1 by 2, 50% is the confidence for our association rule if white and then blue for us. So this is what we have to understand. Now, what is the next problem that you can solve? Let us try to solve another problem. What is the support, or it should be what is the confidence for our association rule if blue, then white? What is my antecedent item? It is blue. What is my consequent item? It is white. So this is what we have to understand first. Now, what is the formula for confidence? Total number of transactions with your antecedent item in the denominator. In the numerator, how many of these antecedent transactions also have our consequent item? So in the numerator, you can write down total number of transactions with your antecedent and consequent item. Now, what is the denominator? Total number of transactions with our antecedent item. What is our antecedent item? It is blue. So how many transactions that you have with item blue? 1, 2, 3, 4, 5. So we have 5 transactions in our data set which are having blue color item. Now out of these 5 transactions, how many transactions are also having white first? 1, 2, 3, and 4. So 4 transactions are also having my consequent item white. So what is the confidence for our association rule? It is 80% false. So what is the important point that we have to understand here? The important point what we have to understand here is when we are calculating our confidence, the order in which the items are purchased is important for us, is taken into consideration. So now, out of these 2 association rules, which rule is important for us? The rule which is having more confidence is going to carry more importance when I'm trying to select my association rules. So if blue, then white is having more confidence. Therefore, it is a better association rule that you can include in your selection of important association rules. What about support? We have initially calculated support. How can I use my support in my association rules model? I can simply say a minimum support for my association rule should be 50%. So when I say this, automatically it is only going to select those association rules which are going to have a minimum value of 50%. So the first association rule, if white then blue, what is the support value we got? 40%. So when I say minimum support for my association rule should be 50%, then automatically this association rule will not be selected because it is not having a minimum support value of 50%. It is less than 50% for us. So like this, you can only focus on those item or item sets which are having a minimum support of 50% for us. So focus on only those item sets which are going to have a minimum support of 50% for us. That is the idea. That is what we are going to do. So we are going to use one library in Python. It is called as MLXTEND. And then this library is going to have our a priori function. And it is also going to have our association rules function. So both of them we can use and we can write down our different association rules. So that is what we are going to see. No need of any manual calculations for your support or for your confidence. Everything will be taken care of by these functions when you are going to use. So everything is ready made for us. Nothing is to be made. So make use of our functions and libraries and you can identify what are your important association rules. That is the concept. So we have seen so far our two measures we have seen. Support and confidence for us. So for any given association rule, you can use our simple formulas that we have discussed here. And you can find out what is the support, what is the confidence for us. So support is transactions with both antecedent and consequent item sets divided by total number of transactions. And confidence is nothing but percentage of antecedent transactions that also have consequent item sets. So you can write it down like this mathematically, P of C given A. And this you can expand it as P of C intersection A divided by P of A for us. So transactions with both our antecedent and consequent item sets divided by transactions with only our antecedent item sets. So that is the idea. How you can calculate our confidence. So both these measures we are going to use in our association rules concept. So this is the idea. So we can solve several problems like this. And we can find out what is the support and confidence. So there is another example for us, what we are going to see in few minutes. How to calculate our support and confidence. We are going to discuss after the break. So take a break here for 10 minutes and then come back to discuss more examples and some more concepts in our association rules. So take a break and come back after 10 minutes. So let us continue our discussion. So we have another problem that we can try to solve here. So we have 4 transactions. So transaction 1, transaction 2, transaction 3, transaction 4. So in the first transaction, our customer is purchasing shoes, socks, tie, and belt. He is purchasing these 4 items. In the second transaction, he is purchasing shoes, socks, tie, belt, shirt, and hat. In the third transaction, he is purchasing shoes and tie. In the fourth transaction, he is purchasing shoes, socks, and belt. So we have 4 transactions. So when you're programming the concept of association rules in Python, we have to convert this transaction matrix into a dummy variable matrix for the sake of convenience, for the sake of applying the concept of association rules. So how can you do this is, you can simply use a function in your pandas library. And you can convert your transaction matrix into a dummy variable matrix for us. pd.get_dummies. This is the function what you can use. So what is going to happen when you apply this get_dummies function? For the first transaction, whatever items have been purchased, shoes, socks, tie, belt, all these items are going to receive a value of 1. Whatever items are not purchased in that transaction, it is going to assign a value of 0. So that is how it is going to create your dummies for different items that you have in your transaction. So there is some network issue here. Yeah. So we have to convert our transaction database into our dummy variable matrix. That is what we are supposed to do. So in the first transaction, you have all these items which are purchased. It is going to assign a value of 1. And all the items which have not been purchased, you are going to get a value of 0. In the second transaction, customer has purchased shoes, socks, tie, belt, shirt, and hat. So all these items are going to receive 1. Other items are going to receive 0. In the third transaction, we have shoes and tie. They are going to get a value of 1. All the other items are going to get a value of 0. In the fourth transaction, shoes, socks, and belt have been purchased. They are going to get a value of 1. Other items are going to get 0 for us. So now, what is the question that we have? We have to find out what is the support and confidence for our association rule If socks, then time. This is what we have to find out. So our antecedent item is socks. Our consequent item is tie. So what is the support? How many transactions you have? 4 transactions we have. Out of these 4 transactions, how many transactions are having socks? 1 and 2. So 2 upon 4, it is 50% for us. What is confidence? How many transactions you have with your antecedent item? Socks. You have 3 transactions. Out of these 3 transactions, how many transactions are also having tie for us? So support for this association rule, if socks then tie, is 50%. And confidence for our association rule, if socks and tie, is 66%. So this is what you have, 2 by 4 and 2 by 3. So this is how you can manually find out our support and confidence. Now, we have just now discussed about the concept of dummy variable matrix, what you have to create on your customer transaction database. So this is your dummy variable matrix, what you have created. Now, on this matrix, you are going so what does your a priori function going to help us? It is going to use this information and it is going to generate frequent item sets first. It is going to generate frequent item sets. So if you have key items, if you are working with key items in your data set, then what is that you are going to do? First, you have to define what is your minimum support criteria. What is your minimum support criteria? You have to define first. If I define minimum support criteria as 50%, then using this definition of minimum support criteria, it is going to generate the list of 1 item sets first. So it is going to give you or create the list of item sets which are having just 1 product. Then using this 1 item set, it is going to create your list of 2 item sets which are satisfying our minimum support criteria. Then it is going to use this list of 2 item sets to create list of 3 item sets which are satisfying our minimum support criteria. Then it is going to use this list of 3 item sets and it is going to create list of 4 item sets first. Our criteria is equal to 50%. So it is going to continue this process for all the items in your data set. For all the items in your transactions, it is going to continue this. So we can simply apply our a priori function. This is what we are going to do. That is the idea. Now, all these steps, remember, again, we are going to apply them in our Python Jupyter notebooks. We are going to see how it is going to work. Now, so far we have discussed the concept of support and we have discussed the concept of confidence first. This is what we have seen. Now there is another performance measure which is called as lift ratio first. This is another performance measure which is called as lift ratio. Now, what is the formula of lift ratio? It is confidence upon benchmark confidence first. This is the formula. So we have a new term now which is called as benchmark confidence. What is that benchmark confidence? We have to understand. First, why do we require this benchmark confidence? Because there is a small disadvantage with our confidence measure. What is that disadvantage? If I write this association rule, if bread, then milk. If I write this association rule, then people who are going to purchase bread are also going to purchase milk. So there is nothing so great in writing these kind of association rules because there is inherent bias. There is inherent dependency between these two products. If a person is buying vegetables, then he will also buy fruits. So there is nothing so great in writing these association rules because there is intrinsic bias between these two items. So your confidence is a measure which will have this bias when it is creating association rules for us. So that is a disadvantage what we have with confidence measure. So now, how can we overcome this disadvantage what our confidence has? How can we eliminate this intrinsic bias between our items? We are going to take the help of benchmark confidence. So benchmark confidence is an alternate measure which will assume the independence between our antecedent and consequent item. So it will assume, it will consider that our antecedent and consequent items are independent of each other. So therefore, benchmark confidence will help us overcome this inherent bias which is there between our antecedent and consequent items. So what is the formula of confidence that we have already seen? This is the formula of confidence what we have already written down. Now, what will be the formula for benchmark confidence now? Benchmark confidence is going to assume that my consequent and antecedent items are independent of each other. When two events are independent of each other, how can you write them? P of A intersection B can be written as P of A into P of B. When two items are independent of each other, we can write it down like this. So P of C intersection A can be written as P of C into P of A first, divided by P of A. So now what is happening? You can cancel P of A in the numerator and denominator, and we will be left with the probability of your consequent item. So your benchmark confidence formula is probability of consequent item in your data set. So mathematically, how can you write this down? You can write this down as In the denominator, total number of transactions that you have in our database, in our data set. In the numerator, total number of transactions with our consequent item sets. That is the formula for calculating our benchmark confidence. Now, why are we calculating this benchmark confidence? Because we want to calculate our lift ratio. So lift ratio is having a formula of confidence upon benchmark confidence first. So confidence we know how to calculate. Now we also know how to calculate our benchmark confidence first. It is nothing but probability. If I give you one problem, can we calculate our lift ratio for that problem? What is the lift ratio for our association rule? If white, then blue first. What is the lift ratio? What is the formula? Confidence upon benchmark confidence first. So what is the confidence? Number of transactions with my antecedent item. How many transactions I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 transactions I have. And in the numerator, how many of these transactions are also having my blue color item? So 1, 2, 3, and 4. So 4 transactions I also have my blue color item. So this is my confidence. What is my benchmark confidence? It is in the denominator, I have total number of transactions, 10 transactions. Out of these 10 transactions, how many transactions? I'm also having my consequent item. What is my consequent item here? It is blue. How many transactions I have blue here? 1, 2, 3, 4, and 5. So 5 transactions I have my blue item. So confidence upon benchmark confidence is going to give you your lift ratio. So 4 upon 8 divided by 5 upon 10 is nothing but 1 by 2 divided by 1 by 2. So what is the answer? It is 1. So lift ratio for our association rule, if white then blue, it is 1 first. So that is how you can use your lift for deciding what are your most important association rules. So we are going to use this in our problem. Lift ratio is equal to 1. So lift ratio is the last and final measure that you can use for finding out what are your most important association rules. You can interpret this lift ratio. What is the meaning of this lift ratio? We'll try to understand. So before we try to understand, it is 7:30. It is that time of the day where we are supposed to fill our details in the attendance sheet. So all of you try to fill the details in the attendance sheet, and then you can come back and listen to our concepts of lift ratio. So how are you going to interpret your lift ratio? So lift ratio greater than 1 indicates that our association rule is useful in finding our consequent item sets. So we have to focus on all those association rules which are going to have a lift ratio value of greater than 1, because they are considered to be the most important association rules which are helping us in finding out our consequent item sets, which are going to help us in finding our consequent items. So instead of randomly selecting our association rules, we can take the help of our 3 measures: support, confidence, and lift ratio, to decide what are our most useful association rules on our data set. So this is the approach what you are going to take. This is what you are supposed to do when you are applying the concept of association rules. So all these measures we have to work out. So focus on all your association rules which are having a lift ratio of greater than 1 for us. That is the idea. Because here there is some power problems, because of which my internet is causing some difficulty. So I hope everybody is able to clearly hear my voice. Now, let us try to summarize all our points, what we have discussed. So lift ratio shows how effective is our association rule in finding our consequent items. So focus on all our association rules which are going to have a lift ratio value of greater than 1 first. That is the area of focus. It is useful for finding our particular consequent items in our data set. Now, what is confidence? Confidence is nothing but it is the rate at which the consequent items will be found. Out of all your transactions with your antecedent item, how many of those transactions are also having a consequent item? So confidence is going to explain us about the rate at which you can find out your consequent items. That is the idea. That is the area of focus for us. Confidence. Now, what do you mean by support? Support measures the overall impact. What percentage of transactions have been affected? You can understand on the basis of support first. So it measures out of it will measure the overall impact of your antecedent and consequent items in your data set. That is what our support measure is going to help us. It is going to give us information about how many of your transactions are getting impacted because of your antecedent and consequent item set. Now, remember these concepts: support, confidence, and measure. Now, some points to remember when you're applying the concept of association rules for us. What are these points? The importance of focusing only on those association rules which are going to have high quality of information. So if you are working with random data can generate apparently interesting association rules for us. So it can generate interesting association rules, but that does not mean you are supposed to apply these association rules in our business. So you have to always find out whether this information what I'm having, is it available in the public domain, or is it high quality information that I can apply in my business. So simply random data is going to generate interesting association rules which may not have any logical explanation, and therefore it is not recommended to apply these kind of association rules in our business. So that is the first important point what you have to understand. What is the next important point? The more association rules you are producing or you're creating or generating, the greater is the danger. So the more association rules you have, then it becomes very difficult for us to decide which association rule is actually going to help us in our business. Which association rule is important for us? That becomes a challenge for us, because the more the number of association rules you have, the more will be the confusion for us. The more will be the confusion for us. So this is the point what you are supposed to remember. So focus only on generating lesser number of association rules so that you can decide based on those association rules which of them are actually going to help me in my business. Next point. Rules based on large number of records is always better for us. So when you generate rules based on large number of records, you can eliminate all your inexplicable association rules. What you have created on your data set. So you can eliminate the role of chance. You can eliminate random data causing some disturbances or trouble when you are trying to create your association rules. So focus on collecting as much data as possible for you when you're trying to create your association rules, because more the data you have, then lesser will be the difficulty when it comes to understanding the random patterns that you can come across in your data sets. So focus on working on large number of observations, large number of data, which can eliminate the role of chance, which can eliminate the problem of random data generating apparently inexplicable association rules, which do not carry any logic. Therefore, be careful when you're trying to work with random data, and make sure that you're not going to apply association rules which are not having any logic in your business. Now, suppose if I give you an example, this is an output what you got after generating our association rules. This is the output what you got. So you have your different association rules here, and then you have the confidence with respect to your different association rules, and you have your antecedent and consequent, you have the lift ratio values, all these things you have. So what is the most important association rule for us? Whichever association rule is having the highest lift ratio value, that becomes the most important association rule for us. So the first rule is the most important association rule. What is this rule telling us? If a person is buying italic cookbooks, then he is also going to purchase cookbooks for us. That is the most important association rule. Then, what is the second most important association rule? If a person is buying art books, child books, then he is also going to purchase geography books for us. What is the lift ratio? 2.27. Then what is the third most important association rule? If a person is buying cookbooks, do-it-yourself books, then he is also going to purchase art books. 2.24. So like this, you have written down all your important association rules in the descending order of lift ratio. In the descending order of lift ratio, we have written down all our association rules. Now, my question to you is, if you look at association rule number 2 and rule number 7, what is the challenge that you are facing? For the same combination of books, there is only a small difference between our association rules. So association rule number 2 is having a lift ratio of 2.27. Association rule 7 is having a lift ratio of 2.17 for us. Now, which is a better association rule for us? How are you going to decide? Because the lift ratio values are very close to each other, very, very close. So that is a challenge what you are going to face. So the lift ratio values may be very close to each other and you do not know which association rule is actually going to help you in your business. Which association rule is important for us to consider? Then what is that you are going to do? You are going to take the help of confidence first. So what is our confidence measure telling us? Our confidence measure is clearly telling us that rule number 2 is important for us because it is having higher confidence value. 62.77% is the confidence of our association rule number 2 compared to association rule number 7. So when you have lift ratio values which are very close to each other, or lift ratio values are equal for your association rules, then take the help of confidence and then you can decide on the basis of confidence which association rule is actually going to help us, which association rule can be considered as important for us in our business. So that is how you are going to decide. When you have very close lift ratio values between our association rules. That is the logic. Okay. Now, how can we program this logic? How can we program our association rules concept in Python? Let us try to understand. Association rules. So what is the first step that you are going to do? You have to install our libraries. What is the library you are going to say? Pip install ML XTEND. So be careful of the spelling. It is not extend EXTEND. It is XTEND. There is no E. So be careful of the spelling and install this library first. Why are we installing this library? Because from ML extend library .frequent underscore patterns, you can import your a priori function and association underscore rules function. Both of them we can import. from this library. Then import your basic library pandas for us. Import it. And you can ignore this piece of code. You don't have to worry about what is there. So install your ML xtend library. Now scroll down. This is how you are going to install your library in your Jupyter Notebook environment. Now read your file. What is the file that we are working on? It is Titanic dataset. We are using Titanic dataset first. It is a CSV file. Now, what are the different columns that you have in your dataset? You have class column, you have gender column, age column you have, and survived column you have. So class column is having different values for us. Third class, second class, first class, and crew class. All these are different values which are present in our class column in our data set. Gender, you are having two values, male and female first. These are the two values what you have for gender. Age is having two values, child and adult. These are the two categories what you have for age. And survived, whether that person has survived the crash or not, Titanic ship crash. So you have values yes and no. These are the two values that you have. Now, so when I say Titanic.head, I can get a snapshot of my top 5 rows in my data set. So you can also view the entire data set, simply remove the head and you can display all your observations in your data set. Now, we are going to pre-process our data. So convert your data into your dummy variable matrix. So use our function get underscore dummies. Apply it on our Titanic data frame, what we have created. Now, what is it going to give you? So my 0th observation, that person has traveled in third class. Therefore, you're going to assign a value of 1. He is a male person. Therefore, assign a value of 1. He is a child. So assign a value of 1. And he has not survived the crash. That is the information what you can get. So all the other columns will be assigned a value of 0 for the 0th observation that you have in your data set. Similarly, first observation what you have in your data set. So that person has also traveled in third class. He is also a male person. He is also a child. And he has not survived our crash. That is the information what we have. So our dummy variable matrix is ready for us. Dummy variable matrix is ready. Now, apply our a priori algorithm. That is what you are going to do. So I'm giving my minimum support criteria as 10%. So this is the value, how I'm defining my minimum support criteria as 10%. So what it is going to do, that same a priori function logic what we have discussed in our presentation, it is going to write down all the item sets which are going to satisfy our minimum support criteria of 10%. So all my item sets are having a minimum support value of 10% for us. So first it is going to start from creating one item sets. Then using this one item set, it will create two item sets. So these are my two item sets, what it is creating. Then using these two item sets, it is going to create our three item sets. These are my three item sets. Then using my three item sets, it is going to create four item sets. So these are my four item sets. All my item sets are satisfying my criteria of minimum support value is equal to 10% false. That is what you're doing here. Now, apply our association underscore rules function. Apply this function on our frequent item sets. Apply that. Apply our association underscore rules on our frequent underscore item sets. What is the metric? The metric that we are going to use to decide our important association rules is going to be lift ratio for us. So metric is equal to lift ratio, and I'm saying minimum lift ratio value should be 0.7. So this I can change. So just for the I'm considering a focus on those association rules which are going to have a minimum lift ratio value of 1. So you're free to do so when I share the program with you. So you can free to change this value. Now, I'm sorting my association rules. After creating my association rules, I'm sorting all my association rules in the descending order of lift ratio. I'm sorting all my association rules in the descending order of lift ratio, and I'm taking a look at my top 10 records. What are the top 10 association rules in the descending order of lift ratio? So what is the first association rule that I got here? My antecedent is that person is female gender and she is adult person. Then she would have survived the Titanic crash. What is the lift ratio value that you are getting? 2.301. Now, this is one association rule that you have. What is the next association rule? That person has survived. Then, if that person has survived, then she must be a female person or she must be adult. So this is also having the same lift ratio for us, 2.30. So which one is a better association rule now? What is the concept that we have discussed just a few minutes back? Select that association rule which is having higher confidence. So the first association rule is a much better association rule because it is having high confidence value for us, 74%. So what is that association rule telling us? If that person is female gender, logical first. So it is a very high chance that a female adult person would have survived the crash, which is having 74% confidence for us. Now, scroll down. We have some more association rules here. If that person is female gender, then she would have survived the crash. So what is the lift ratio? 2.26. So these two association rules are again having the same lift ratio value. So what is that you are going to do? Go for that association rule which is having higher confidence. So if that person is female, then she would have survived the crash. we have around 73% confidence in that association rule. So this is a better association rule for us. Now, we have two more association rules. If that person is female gender, then she would have survived the crash and she is an adult person first. This is having a lift ratio of 2.26, 2724. And we have another association rule. If that person has survived and that person is adult, then she would have been female. So which one is better now? Go for the association rule, which is having more confidence for us. If that person is female gender, that means she would have had a very high chance of surviving the crash and she is an adult person first. So this is another important association rule for us. Now you have two more association rules which are having same lift ratio value. So if that person has not survived the crash and he is traveling in crew class, then that person must be male person and adult. This is having a lift ratio of 1.314. And if that person is male gender and if that person is adult, then he would have not survived the crash and he would be traveling in crew class. So which association rule is better? Which is having more confidence for us. So if that person has not survived the crash and traveling in crew class, then he would have been a male person and adult. So this is our important association. Then again scroll down. Then you have another set of association rules which are having same lift ratio values. So what is that you're going to do? If that person is male gender and if that person is adult, then he would have been traveling in crew class. If that person is traveling in crew class, then that person would be male gender and adult. So which one is better for us? Go for the association rule, which is going to have more confidence for us, 0.97. So like this, you are going to shortlist your top 5 association rules and you are going to share it with your client or subject matter expert. And you are going to talk to him about your importance of these association rules. Apply them on your business. See and apply them if they are actually going to have any significance for us, if they are carrying any importance. So that is how you have to decide. So what kind of items or products can have association based on your support, your lift ratio, and your confidence. So this is the piece of code what you can use for your association rules. So that's all what we have for today. And we are going to continue our discussion with some more unsupervised machine learning topics in our tomorrow's discussion. And we'll try to apply them in our Python Jupyter notebooks and we'll try to analyze what are those concepts. So with that, please try to revise all the topics what we have discussed so far whenever you find time. And what is the most important thing you are supposed to do? You are supposed to practice these codes. So I'm going to share this piece of information with you and you will be able to access this information very soon, maybe in a day or two. You will be able to get them on your LMS platforms and you can take a look at the data sets and also your Python programs, what we have discussed in class. So all these things will be made available for you in a day or two and you can always practice them. So thank you very much for your time today and I'll see you all tomorrow.